For Algebra 2, and we're looking at trig identities, and we're proving this particular equation right here. We have cosine x over 1 minus sine x minus cosine x over 1 plus sine x equals 2 tangent x. Alright, so let's begin to work this out. So I want to start my work by looking on the left side because it's the most complicated side, and that's the one that I want to simplify to look like the right side, 2 tangent x. So cosine x over 1 minus x minus cosine x over 1 plus sine x. So I see here that I have a subtraction problem with, it's in a fraction form, and I want to be able to combine both of these. So I want to make sure, I want to work this out so that they have the same common denominator. Going back to our rules of subtracting fractions, you need a common denominator to be able to do that. So let's simplify that. So that means that on the left side, I'm multiplying by what's on the right, 1 plus sine x, and then on the right side, I'm multiplying by what's on the left denominator position, 1 minus sine x. And so of course, whatever I do to the denominator, I must also do to the numerator. So let me work out this right side so you can see how I do this. I'm going to end up doing distribution. Okay, so I'm going to distribute cosine x to 1, which gives me cosine x, and then cosine x minus, or cosine times negative sine x gives me a minus cosine sine x. And so that's what I'm going to end up replacing that numerator with, is that. So I've simplified that now, and now I'm going to turn my attention to the left term, and I'm going to do the exact same thing, but I'm just going to go ahead and give you what I ended up getting for that. And that's that right there. So let me clean this up a bit because it's getting kind of messy here. So let me take a step back. Notice the subtraction sign. That subtraction sign, I am subtracting the entire term on the right hand side. So notice that I put the term on the right side in parentheses, so I know that that minus sign needs to be distributed within each one of those terms. And once I distribute that minus sign, I end up with, let me back up here. Actually, yes, let me back up here. So notice in the denominator, I'm going to go ahead and clean up my denominator first. So now that I have the same denominator, I can clean it up, and that's my new denominator. Okay, now let me go back to the numerator and distribute that minus sign into both of these terms. So I end up with, since cosine x is positive, it will go negative, and since minus cosine x times sine x is negative, it will turn positive. And here goes. So I distribute it, and that's what I get now. And now I have this is basically a big plus addition and subtraction problem now. And so now I just need to find the like terms. Okay, I need to find the like terms in the numerator, which are these two right here. I have cosine x minus cosine x. So I end up actually just canceling each other out. So now I'm going to clean up my numerator, and I end up with this. I end up with cosine x sine x plus cosine x sine x. So those are two like terms, so I end up with two of those, so I have the coefficient 2 for them now. So as you can see here, this is starting to clean up nicely. And the numerator, I still have two terms. So I want to factor those terms out and see what I get here. So I'm going to factor the 1 to the 1. So I'm going to FOIL. Actually, I'm not factoring. It's already factored. I'm going to FOIL. So 1 times 1 is 1. And then 1 times sine x is plus sine x. And now I'm going to do the innermost. So I have negative x, and then I end up with negative sine squared x. And so these two terms are going to cancel out because I have plus sine x minus sine x, leaving me with 1 minus sine squared x. So that's what I'm going to replace my denominator with now. So now my denominator position cleans up with this. So now I'm kind of stuck. Now what do I do next? Well, this is where memorizing the identities comes in handy, because if you look at 1 minus sine x sine squared x, this isn't directly look like one of the identities, but you can derive this particular term from an identity. So if you look at your identities, you'll know one identity that has the sine squared x and 1 in there. So if I look at this identity, I can actually derive, or I can switch this up to make it look like this. So look at what happens when I subtract the sine x on both sides. So that cancels out, and I end up with cosine squared x equals 1 minus sine squared x. So that denominator, 1 minus sine squared x, actually equals cosine squared x. And at this point, now I can actually cancel out one of my cosines. And to clean this up, I end up with 2 sine x over cosine x, which happens to be 2 tangent x. And that does it. So I've just proven this equation to actually equal each other out. So this is true. All right, well, I hope this helped, and good luck in your study.